I will check it, like I said. I'll borrow it real quick. Check it as soon as we finish the lesson, okay? Alright, today is lesson 19. I need everybody following along on page 67. And today, yesterday we started our fractions. Today we're going to pick up where we left off. Yesterday we subtracted and we added. We didn't actually do any subtraction practice, but it's going to be the same. Or no, yesterday we multiplied. I'm getting ahead of myself. We multiplied, you had a number 2/5 of, so that of is what came into play yesterday. I take that back. So today is just going to be giving it different names or words. So we've got different signs for multiplication. We can use that X, like you guys have seen a million times. We can use the little dot. We can use the little dot, okay? That also means multiply. So if you see the little dot between numbers, that means multiply. Another way that we can write is with the parentheses. So if you have parentheses around a number, that means multiply them together, okay? If one of the numbers has parentheses around it, that means multiply them together, okay? The 4 could be in front or behind. If something's in parentheses and there's no sign between them, that means multiply, okay? So, I think you guys understand the signs. And then multiplying fractions is the same as we did yesterday, but instead of the whole numbers, putting them over 1, you're going to be given 2 different fractions. So the first example, 19.1 today, is 4/9 times 5/7. 4/9 times 5/7. Again, yesterday we talked about if they have anything in common, you can reduce. I'm sorry?
Please view my DRSM.
We're not worried about that quite yet. We will talk about order of operations in a little while. But today we're just talking about multiplying fractions, and we can reduce. Same as yesterday, we're just taking it a step further. If you have a couple fractions, you could even have 3 or 4 different fractions you all multiply together, and any number on the top can compare to any number on the bottom. Okay, so do any of these numbers have anything in common? Can 4 go into 9 or 7? Nope. Can 5 go into 9 or 7? Nope. The only non-prime number we've got up here is 4, but nothing else is divisible by 2. So we know that when we do this math and we multiply across, 4 times 5, 20. 9 times 7, 60-something, 63. Good. 20 over 63 is going to be in the lowest terms. Since we couldn't reduce anything over here or cancel, that is our lowest terms. Okay? So, next example is 2/3 cubed. 2/3 cubed. And we learned that cubed means you're going to need to take this number and do what with it? Travis? Multiply 3 times. 3 times by itself, right? 2/3 times 2/3 times 2/3. Okay? Nothing compares. 2's on the top, 3's on the bottom. So we can multiply across. And 2 times 2 times 2 is what? 8. And 3 times 3 times 3? Careful. 27. Good. So, 2/3 cubed equals 8 over 27. Okay? Perfect. The next example. Alright, so if numerators and denominators, let's just read that paragraph real quick. 67, bottom of the page. If the numerators and denominators contain common factors, it's helpful to simplify or reduce before multiplying. So again, what we were talking about, and we're going to get some examples in a second. So the terms of fractions may reduce before they are multiplied. So if we consider 3/8 times 2/3, rather than doing the math and getting 6 over 24, we could take that 2 and that 8 and cancel. We can take those 2 3's and cancel down. Okay? So let's all flip the page. Okay? Canceling only applies, make sure everybody's turning their page, only applies to multiplication and division. Okay? Division, we're going to have to make sure we set it up before we cancel. But once we've got everything set up to multiply, we're going to be good to go. Okay? So for our first one, 4/9 times 18 over 30 I always want you guys to practice canceling beforehand to make your lives and reducing a lot simpler. Okay, so 4 ninths times 18 over 30. So what do we see that they have in common? Travis? Well, do 4 and 9 have anything in common? You start here? Okay. I like to. 4 and 30. Do 4 and 30 have anything in common?
Yeah.
What do they have in common? 2. So if you divide them both by 2, 4 becomes 2, and 30 divided by 2 becomes exactly 15. So make sure that you keep them close so that you know the 2 is still on the top and the 15 is still on the bottom, because you're still going to have to include those numbers in multiplication if they don't reduce again. Okay, do we see anything else that can reduce? What else can reduce? So 9 and the 18. What do you want to divide them both by? 9. By 9. Okay, so 9 divided by 9. 18 divided by 9. 2. So now 2 and 1. 2 and 15. Do 2 and 15 have anything in common? Nope.
No.
Nothing for 2 and 15. So now we've got everything as simple as possible. We can multiply across the top and then multiply across the bottom. So across the top, you've got 2 by 2. Come on, what's 2 by 2? 4 and 1 by 15. Come on. What? 1 by 15. 15. Good. So 4 over 15. 4 ninths times 18 over 30 is 4 over 15. Okay? Next one is dividing fractions. Okay? I think somebody in here has already said it. We do KCF. Keep, change, flip. Okay? So if you've got 21 over 6 divided by 27 over 4. Okay? We're going to keep the first one. We're going to change the sign to multiplication, and we're going to flip the one that's second. So this will turn into 21 over 6 times, change it, and flip it, 4 over 27. Have you guys seen this before? Yes? Okay, I figured as much. So, keep, change, flip, okay, is dividing fractions is multiplying by the reciprocal. Okay, the reciprocal means we flip it. So, now that we've got it all set up for multiplication, can we cancel anything? Can we reduce those before we multiply? I see Damon shaking his head. What do you want to reduce, Damon? What do you want to reduce? The 4 and the 6. Okay, what do you want to divide them by? 2. What's 4 divided by 2? 2. What's 6 divided by 2? 3. Okay. Anything else? Jamaica, what do you want to do next? Jamaica, what would you like to do next?
Divide some by some.
Divide something by something. Pick something for me. Jamaica. Just Jamaica. What do you want to do? What do you want to simplify? You can compare 21 and 3. 21 and 20. Okay. 21 and 27. So what do you want to divide them both by?
I say 21 with a 7.
Oh, with a 7. What would
Like you 3 divided by 7.
Okay, can you divide anything else up here by 7? No. So we need to pick a number that has something in common. So here, Damon told us we're dividing by 2. Both of these have to be divided by 2.
7 and 9. 9 by 2. Don't 9 go out there?
9 goes into what?
I ain't saying 9. I said 3.
3. What do you want to divide by 3?
Both of them.
Both of what?
The 21 and the 27.
There you go. 21 and 27. We'll divide them both by 3. So 21 divided by 3 is?
76.
And 27 divided by 3? Okay. 9. So now we have 7, 2, 3, and 9. Can anything else? Can 7 and 3 compare? Travis?
What is one side like when you cross?
We're not cross multiplying. Be careful with the words, okay?
Well, I told like you did, if you go across and one side you can divide and the other side you can't. What you do?
So like this one, if it was 27,
Like
21 and 6, so that became 3. You could, another way to look at this one,
and yeah, and the other side.
okay, so we could do 21 and 3 instead. you could change that to a 1 and change that to a 7. Because 3 and 21 have something in common. Does that make sense? Okay, so we're still going to get the same answer, right? Because 1 times 27 is the same as 3 times 9. Does that answer your question? No. Okay, you want to ask again? No?
What about their bottom?
What about what bottom?
You can still reduce that 3 and 9.
Here?
Yeah.
Okay, we can't compare the bottoms to each other. You can only compare the bottom to a top. You can only pair one on the top with one on the bottom. Same as a fraction. You're essentially just picking a piece of this fraction to reduce first before you multiply. Does that make sense? Okay, so bottom, they're always going to have to multiply, so we can't reduce anything when we multiply. We can only reduce when we look at the top versus the bottom. So this answer, 7 times 2 on the top is going to be what?
14 over 27.
Good. 14 over 27. Okay? So, as long as you guys have keep, change, flip, or multiply by the reciprocal, you've got dividing fractions, and you're going to be good to go. Okay? So, yep, it is time for the practice. A, B, and C. One second. A, B, and C on page 68, and I will clear you, and then you may start on your homework.
What?